Good morning, it's Mrs. Kane, and I'm here with your next lesson. I'm going to be continuing to talk about solving exponential and log equations today. In the warm-up, I'm going to review the change of base formula that I taught on in Monday and Tuesday's lesson. We're also going to talk about a restriction that we have when we do logarithms. We have a restriction in the argument, so I'm going to talk about that a little bit during the warm-up. And then we're specifically going to be talking about solving logarithmic equations today. At the conclusion of the video, I ask that you go ahead and try the problems in the circuit. Do the best you can, kind of use the answers to guide you. And then I will be providing some feedback to you individually, and I'll post a video later this week with some explanations. All right, so for our learning target today, I can solve exponential and logarithmic equations. So for the warm-up, it says use the change of base formula and a calculator to evaluate each logarithm. So all you have to do when you use the change of base formula is you're going to take the base of the common log of the argument. So in this case, we're going to do log of 2,187. And I'm going to put that in parentheses. I'm going to divide by log of 3. Okay, so this change of base formula allows us to type logs in our calculators. So you're going to hit the common log button and then divide by, hit the log button and then type 3. And so we find that the answer here equals 7. And I'll go ahead and highlight that. Okay, so for the next one, we have log of the argument is 1 over 625. And then if I want to put that in the calculator, I'm going to divide by the common log of 5. Okay, so I'm going to do, log of 1 over 625. You can also use the fraction key if you want, and then divide by log of 5. And this time the answer is -4. And it shouldn't be surprising that the answer there is negative, okay, because you're starting with a base of 5 and your answer is 1 over 625. So 5 to the -4th is 625. Now, in the next problem, we're going to do log of -9 divided by log of 3. And what you're going to notice in the calculator is that you get an error, and it says non-real answer, okay? And so the reason that we have an error, and we kind of say this is not possible or undefined, okay, is because that argument has to be greater than 0. Okay, so the -9 is called the argument, and you cannot take a log if that argument is negative. 3 to what power equals a negative? Okay, so that's not it doesn't work out when that argument is negative. Okay, is it okay if that argument is 0? 3 to a power equals 0, is that possible? It doesn't seem likely, okay? Log of 0 divided by log of 3, okay? So is there an exponent that we can raise 3 to get the number 0? Not that I can think of in my head. And notice if we use the calculator to kind of verify our hunch, it's also an issue, okay? So this is also not possible. So this argument, this number that you take the log of, has to be greater than 0. Okay, so it can't be negative and it can't be 0. So again, this one is also not possible. So a little review of that change of base formula, but also just pointing out that it's not possible to take a log of a negative. Okay, so what we found here, the argument of a log must be positive. Okay, so in general, if you're given log base b of a has to be greater than 0. Okay, we call that part the argument. Therefore, when we're solving an equation involving a logarithm, we must check our answers. Okay, so if we're trying to solve for a variable that is within the log, it's part of the argument, we have to make sure that that argument is positive. A solution that creates a negative argument or an argument of 0 is an extraneous solution. So we talked a little bit about extraneous solutions when we talked about rationals. We were not allowed to get values that caused division by 0. And when we solved radicals, we had to make sure that that value of x did not cause us to take the even root of a negative. Okay, so now we're going to take a look at how to solve a few different types of log equations. So the first type of equations that we're going to look at are going to have the word log on both sides. Okay, and these are the easiest types of log problems to solve. If a logarithm is set equal to a logarithm, just set the arguments equal and solve. Okay, so what that means, if we look at this first problem, we have log base 4 of x plus 3 equals log base 4 of 8x plus 17. So if these logs are equal and the bases are already the same, then the arguments have to be the same. Okay, equal means the bases are the same, the arguments are the same. Okay, the key here is that you see the word log on both sides. So all you do is set x plus 3 equal to 8x plus 17. Okay, and then from here, I'm going to go ahead and subtract 8x from both sides. And I get negative 7x plus 3 equals 17. And then I'm going to subtract 3 from both sides, and I get negative 7x equals 14 divided by negative 7, and x equals negative 2. Okay, now you need to check your answer to make sure that the argument is not negative. So what that means is look at this part right here, put negative 2 in for x, and make sure that you don't get a negative number. So notice on the left side, I get log base 4 of negative 2 plus 3 is 1. And so that's fine. You can take the log base 4 of 1. And then on the right side, I get log base 4 of 8 times negative 2 is negative 16, plus 17 is also 1. And so this answer does indeed work, and so I'm going to go ahead and highlight it. Okay, so the next one, we have a common log. Log of x minus 9 equals log of 3x minus 13. So both of them have a base of 10. Okay, I see the word log twice, so I'm just going to set x minus 9 equal to 3x minus 13. I'm going to subtract 3x from both sides. I get negative 2x minus 9 equals negative 13. And then add 9 to both sides. Negative 2x equals negative 4. And then x equals positive 2. Now, my value of x is positive this time, but notice if you check your answer right here in the argument, okay, if I put 2 in for x, I get log of negative 7. And then on the right side, I get 6 minus 13, log of negative 7. You cannot take the log of a negative. Okay, so we cross this out. This is extraneous. And instead, we say that there are no solutions. Okay. All right, so the next type of solving problem we're going to move into, again, this is when we're solving log equations. Okay, so if there's the word log on both sides, set the arguments equal to each other. Now, what if we only have the word log on one side? Okay, these are easy as long as you know how to convert a log to an exponent. Okay, if the equation involves a single logarithm, rewrite the logarithm in exponential form and then solve. So all you have to remember here is to solve a log, change it to an exponent. Just like when we learned to solve exponential equations in the first lesson this week, you change it to log form. So logs and exponents kind of undo each other. So what we're going to do here is we're going to change this to exponential form. So we're going to write 4 squared equals x plus 3. And if you can remember that very first step, change it to exponential form, the rest of the problem becomes pretty simple. Okay, 4 squared is 16. And then all you have to do is subtract 3, and we get x equals 13. Okay, if I do a quick check of the argument, 13 plus 3 is 16. And so it's not extraneous. I'm going to go ahead and highlight it. Okay, remember if no base is written, the base is 10. So if we look at part B, I'm going to put a 10 here as the base. I only have the word log written on one side. Do not say x plus 1 equals 3. Okay, I have to change this log to exponential form. So 10 to the third equals x plus 1. 10 to the third is 1,000. And then all you have to do is subtract 1, and so x equals 999. And if I check the 999 in my argument, I get positive 100, and so my answer is good. Now, in the next problem, notice you have a extra 2 out in front. 2 times log base 2 of x minus 4 equals 6. So before I'm ready to change this to log form, I'm going to divide both sides by 2. And so I get log base 2 of x minus 4 equals 3. I only have the log written on one side, so from here I'm going to change it to exponential form. 2 to the third equals x minus 4. And then 2 to the third is 8. And then add 4 to both sides, and so you get x equals 12. 12 minus 4 is 8, so it works. Okay, so again, the key is change the log to an exponent if you only have one log written. Now, the last set of examples, it says sometimes we need to use the properties of logs to condense a logarithm before solving. All right, so in the next set of problems, we're going to use either the product or the quotient rule. Actually, we're going to be using, looks like we're going to be using the product rule in both of these. Okay, so in order to solve these, we're going to start by condensing the left side of the equations. So in this problem, we have 2 logs on the left and 1 log on the right. Okay, but we learned last week to condense the left side into a single log. So I'm going to write this as log base 3. I'm going to condense these, and when I condense addition, I use multiplication. So I'm going to do log base 3 of 4 times x plus 1 equals, I'm going to keep the log base 3 of 5x minus 3. Okay, so now I have the word log on both sides, and so all I have to do is set my arguments equal to each other. So I'm going to distribute the 4 to get 4x plus 4 equals 5x minus 3. And then from here, I'm going to subtract 4x from both sides. I get 4 equals x minus 3. And then if I add 3, I get x equals 7. Do a quick check. 7 plus 1 is 8. That's good. 5 times 7 is 35 minus 3. That's positive. And so my answer is x equals 7. Okay, again, the key here is that I had the word log written on both sides. Okay, and so therefore, let me kind of color code this a little bit. Therefore, all I had to do is set my arguments equal to each other. Now, notice the very distinct difference between A and B. In part B, we have the log written twice on the left, and we don't have a log on the right. Okay, so we're going to condense the left side using multiplication. So I'm going to write log base 6 of, I'm going to multiply 8 times x minus 2 equals 2. Okay, so I only have the word log written on one side. I'm going to start by distributing this 8. Log base 6 of 8x minus 16, okay, equals 2. Now I'm going to change this to exponential form. 6 squared equals 8x minus 16. So 36 equals 8x minus 16. And then add 16 to both sides. Okay, and then the last step is to divide by 8. 52 divided by 8. 6.5. Okay, and notice if I do a quick check of 6.5, my argument is positive, so it is not extraneous. And so we get x equals 6.5. Okay, so I'm going to have you go ahead and work on the circuit review. I have a discussion page posted on Schoology, and I'm going to try and be available to answer questions. I'm going to set up an optional Google Hangout in the afternoon that I'll put an update about. So I hope these notes made sense. Thanks for tuning in, and I will be back with more lessons next week.